Hi students, in this session I am going to explain you inductive, mesomeric and hyperconjugation effects, and we are going to see its application. And we all know that this is the fundamental of the organic chemistry. Once you understand these concepts, your organic chemistry will be easy for you and you can crack any kind of questions. Please listen to this. Okay, and this is very easy and you have to think, apply only your logical thinking. Okay, so inductive effect. First, I will read out, then I will explain you. Okay, so it arises due to the electronegativity difference between two atoms forming a sigma bond. This is very important point, and it is transmitted through the sigma bond and not through the pi bonds. Pi bonds are not at all involved. Okay, so pi means here, this one, sigma means here. The magnitude of inductive effect decreases while moving away from the group, causing it, and it is a permanent effect. And before going to this, you have to remember, see, in the periodic table, carbon, nitrogen, oxygen, fluorine, you know this series. From carbon to, when we move from carbon to fluorine, okay, the electronegativity increases. So your organic compounds or hydrocarbons, it is made of mostly carbon and hydrogen. So almost they have closer electronegativity, but it has the least electronegativity value. Okay. So you please remember this. So any compound, any sigma bond, if you take, okay, there will be an electronegative difference, isn't it? So only for carbon and carbon, there will not be any electronegative difference because they are made up of the same element and no electronegative difference. But once we introduce a halogen, so you see carbon and where is the carbon and where is the halogen? There is a huge electronegative difference, isn't it? So carbon comes around some 2.4 and it will be some more than 3. Okay, so there is an electronegative difference. So there are all we know in a sigma bond there are 2 electrons, isn't it? So due to this electronegative difference, the electrons will be under the control of the atom which is having more electronegativity. Here which one is going to dominate? Obviously your chlorine is going to dominate because it has a high electronegative when compared to carbon. So what happens? So we used to put this arrow mark. So it says that the electrons are flowing towards the chlorine from carbon to chlorine. So always the arrow mark will be towards more electronegative atom. Okay, so imagine if the carbon chain is this much length. Okay, so what happens? Since it pulls electrons, chlorine attains a partial negative charge, and since carbon is donating, see, it is a sigma bond only and it is a covalent bond only, but the electrons are under the control of it is more closer to chlorine. Okay, that is what we are going to say. We are trying to say. So here it attains a partial positive charge. Okay, so it arises due to the electronegative difference between the two atoms. Okay, so here it is carbon, it is chlorine. So there is an electronegative difference. So here the electrons are moving towards a high electronegative atom. It is transmitted through the sigma bond, only through the sigma bond and not through the pi bond. And you know what is a sigma bond? If it is a single bond, carbon-carbon single bond is a sigma bond. In carbon-carbon double bond, one of the bond is sigma and one is a pi bond. Please remember. Okay. Here in a triple bond, okay, and we have one sigma bond and the rest of the things are 2 pi bonds. Okay, so please remember it operates only through the sigma bond, and the magnitude of the inductive effect decreases while moving away from the group. See, here is the chlorine, so the effect will be more on the first atom. This is 2 bond distance away, this carbon, so the effect will be less when compared to the first one. So it will having very much partial positive charge. Okay, very partial positive charge. And this is a third carbon, which is 3 carbon distance away, 3 bond length distance away. So here del plus. So that means it is very trace amount of partial charge. The effect of this chlorine is very much very tracely felt in this. So when you move away from chlorine further and further, the effect decreases. The effect is maximum in the first carbon. That's what we are trying to say. Okay, clear students? Then this inductive effect is we can divide into 2 types. Okay, so we all know this. One is a negative inductive effect and another is positive inductive effect. So inductive effect, we represent it by I effect, Okay, if it is negative, it is minus I effect. If it is positive, it is plus I. We denote it by plus I. So what is negative inductive effect? Negative inductive effect is due to the electron withdrawing group. So EWG is electron withdrawing group. So what it will do? It will withdraw electrons. So like chlorine only, it will withdraw electrons. It will pull electrons towards itself. So these are highly electronegative groups. You please remember this, and I am going to tell you you need not remember. Just while seeing the group itself, you can assign whether it has negative inductive effect or positive inductive effect, also a positive resonance effect or a negative resonance effect. I am going to explain you. Okay, please watch the video without skipping. Okay, so these are the groups. So this is ammonia, and it is a quaternary ammonia. Having, what is the difference? It has lost its lone pair. No lone pair is there in ammonia. So usually ammonia will be like this, no? So ammonia pluses, it has lost its lone pair. So it is highly electronegative. Okay, so then comes your nitro, cyano, then your sulfonic acid, your aldehyde carbonyl, keto carbonyl, acid carbonyl, acyl carbonyl. Okay, this is what? Amide. Then all your halogens. Then comes your hydroxyl, your alkoxy, your amine, then your benzene and your hydrogen. Least is the hydrogen. Usually hydrogen is neutral. It will neither give or not, it will withdraw. Okay, so that is the nature. So we have kept it at last. Okay, so positive inductive effect. Positive, it is very easy to remember. Most of the positive inductive effect means, I told you, these effects is given by occurs by the electronegative difference. Okay, so carbon. Okay, so alkyl groups, all kinds of alkyl groups are electron donating. Other than, you know that apart from carbon, all other atoms are highly electronegative than carbon. So whichever atom starts with, okay, so all these are highly electronegative, and only your alkyl groups are made of what? Pure hydrocarbons, pure carbon hydrogen, they are donating. Okay, so I am going to, at last in between I will tell you a hint to remember. Okay, so here, so what happens when a carbocation, okay, when a carbocation is attached to a methyl group. So between carbon and carbon there is no electronegative difference. Okay, but here hydrogen and carbon, which is more electronegative? Carbon, isn't it? So they see the flow of electrons from hydrogen to carbon. So what it will do, this carbon will donate the electrons to this carbocation. The carbocation is already deficient in electrons, so it will stabilize this carbocation. So what happens? So the rest of the valencies are hydrogen. So one more valency I am going to substitute with another methyl. Okay, here only one methyl is present. No, I am going to substitute with another methyl. So what happens? This methyl will also donate electrons. Where this electron comes from? From hydrogen. Okay, so due to the small electronegative difference, the hydrogen, it has partial negative charge, not much. So this will also give electrons. Okay, so here again I am going to replace the another hydrogen also with the methyl group. So what happens? There are 3 methyl groups to stabilize this carbocation. So that's why the tertiary carbocation is more stable. Okay, is more stable than the secondary one. In turn, it is more stable than the primary carbocation. This is the reason. Okay, due to the plus I inductive effect of the methyl group, your alkyl group. That's why your tertiary alkyl is more contributing, okay, than your secondary alkyl, primary alkyl, your methyl, and then comes your hydrogen. So how to remember this? See how to remember this. Your positive inductive effect will be given by your alkyl groups, be it anything. Okay, whether a branched chain, a tertiary, a primary, okay, alkyl groups or plus I effect will donate electrons through a sigma bonds. Okay, negative inductive effect. How to remember this? So so carbon, when there will be an electronegative difference when carbon is attached to any other atom other than carbon, whether it can be nitrogen, oxygen, sulfur, rest of the other atoms are electronegative than carbon. Okay, so here it is nitrogen and this is nitrogen, highly electronegative, so it will be minus I effect. Here you can ask it is carbon only, no ma'am, but here see carbon triple bond N, that means what it is attached to nitrogen 3 times, so which makes the carbon more electronegative, so that's why it is highly electronegative. Here it is sulfur. Okay, here carbon only, but how the structure it is, carbon double bond O, so it is twice it is bonded to oxygen. In turn, oxygen is a highly electronegative atom, so which makes this aldehyde very electronegative. This is what carbon monoxide, so ketocarbonyl, and this is what acid carbonyl, this is acyl carbonyl, and this is amide carbonyl, and your halogens, and better try to remember the sequence also. And oxygen, which is highly electronegative, this is alkoxy, which is highly electronegative, nitrogen, your benzene ring, and your hydrogen. Okay, so check for the electronegativity. If it is what purely alkyl, purely hydrocarbon, it will be positive, and rest of the things are negative. Okay, so then next we are going to see the resonance effect. So what happens, it is a delocalization of electrons occurring when an electron withdrawing group or an electron releasing group is attached to an unsaturated system. Okay, it is represented by M or R, depending it is negative resonance effect, it is represented as minus R, positive means it is plus R. So I will tell you what it is. So when a group, when it is attached to a double bond, a system like this, okay, or a group when it is attached to a unsaturated system. Unsaturated, it can be a pure alkene or an aromatic system. Okay, so what happens, a delocalization of electrons takes place. So what is delocalization? If it is an electron donating group, so it will donate electrons like this, so you will have a resonance structures. So I am not writing what group it is, so here, so these are resonance structures. If it is an electron withdrawing group, so what it will take the electrons. So this is delocalization of electrons on one atom to the another atom. Okay, so what are the groups? So the minus resonance effect or the negative mesomeric effect is given by the electron withdrawing groups such as your nitro, your carbonyl, your cyanide, and your acid and your sulfonic acid. See, remember students, some of the groups will have both negative effects, negative inductive effect and negative resonance effect, and some of the groups have negative inductive effect and positive resonance effect, but I will tell you how to remember them. It's very logic, you need not by heart. Okay, so plus R resonance effect. So what it is given by the donating groups such as hydroxyl, alkoxy, your thiol, your amine, your alkylated amine, and your halogen. So I am giving you a clue. Okay, so here minus R effect. Okay, the groups will have unsaturation in it. What is unsaturation? If you write nitro group, so the nitro group can be written as, see, this is the nitro group. This is the nitro group. It has an unsaturated bond. Here carbonyl, it has a C double bond. It is also having an unsaturation. And cyanide, it is also having unsaturation. And acid, it is also having unsaturation. And sulfonic acid, it is also having unsaturation. Okay, so these are the clue to remember. Okay, minus R effect will be given by the groups which is having unsaturation will be there. Okay, whether it is a triple bond or a double bond will be there. Okay, then, so this is the clue, unsaturation. Unsaturation, whether it can be a double or a triple bond will be there. That is the clue. Plus R effect. So all the groups that shows plus resonance or positive mesomeric effect will have lone pair electrons on it. Okay, remember. oxygen and nitrogen, sulfur have lone pair. Even halogens have lone pairs, 3 lone pairs. But the thing is, it is highly electronegative, so it will not tend to donate. Okay, but it is having plus R effect. So what is the clue, students? It will have the lone pairs is the clue. They will have lone pairs. The minus R effect, what? There will be an unsaturation. Okay, so check for this. And it will operate only in what? The double bond system. Okay, unsaturation. Resonance effect, if you see, it will not operate in a sigma bond. It will operate only in pi bond. So remember, that is the difference between resonance effect and inductive effect, and please remember this one. Okay, so then your hyperconjugation effect, and then we are going to see the application. So what is a hyperconjugation? The delocalization of sigma bonds into the adjacent pi orbital. Okay, this is called hyperconjugation. The main important thing is there must be an alpha CH group attached to the sp2 hybridized carbon. So I will tell you what is the delocalization of sigma electrons and what is the pi orbital system. Everything I will tell. See, they have mentioned an sp2 system must be there and an alpha hydrogen. So what is an sp2 system? Examples are alkenes, a carbocation or a free radical or a sp2 hybridized. See, if we have a CH double bond CH2, this carbon is sp2 hybridized, isn't it? If it is a double bond, carbon double bond, the carbon is sp2 hybridized. If it is triple bond, it is sp hybridized. If it is single bond, then it is sp3. So please remember this. So this is the system, okay, an sp2 system. The immediate carbon, we call it as what? The alpha carbon. If you consider this is the system, entire system, or this carbon is the particular carbon. So the very next atom we call it as sigma carbon. If it has, okay, alpha hydrogens, if it has hydrogens, then it shows a peculiar resonance structures. What it is, an effect known as hyperconjugation. So what happens? See here in this bond, two atomic orbitals have combined to give a molecular orbital in which there are 2 electrons, isn't it? So there are 2 electrons. So what happens here? The hydrogen dissociate as proton, and these 2 electrons will come and sit here. The minus charge is what? 2 electrons. Okay, and these 2 electrons will undergo resonance. This will undergo resonance. So what happens? So meanwhile, the proton, the hydrogen will stay as proton, and it will stay near to the structure. So it is a resonance structure. So since there is, in the resonance structure, since there is no bond between the carbon and hydrogen, it is called a no bond resonance. No bond resonance, and it is also called Baker-Nathan effect. What is called? Baker-Nathan effect. So depending on how many hydrogens are there, we can write similar contributing no bond resonance structure. So how many structures we can write? See here we have 3 protons. Similarly, these 2 hydrogens will also undergo the same no bond resonance effect. So the number of alpha hydrogen increases. So here now this hydrogen is going to stay. So the number of hydrogen increases, the number of resonance structure increases. The number of resonance structure increases, the stability increases. So the alkene is more stable. Okay, so how many structures I have written? 3 structures, because 3 alpha hydrogens are there. So 3 similar no bond resonance structures I can write. Okay, the same effect takes place when you have a carbocation. This is also sp2 hybridized, isn't it? So a carbocation is attached to a methyl group. Okay, how many structures? How this carbocation is stabilized? It is also through the inductive effect and also through this is an sp2 hybridized carbon, and this is the alpha carbon. And how many hydrogen it has? It has 3 hydrogens, and it is stabilized by 3 no bond resonance. 3 no bond resonance. Okay, so if I take, okay, this structure, this carbocation, and it will be stabilized by, this is alpha carbon and this is also an alpha carbon. Here there are 3 hydrogen and here there are 3 hydrogen. So 6 no bond resonance structures you can write. Okay, so when compared to, so this is okay, so here how many hydrogens? So you can write 9 no bond resonance structures. So more the number of alpha hydrogen, more the number of no bond resonance, more is the stability. So the stability of the tertiary is more than the secondary and more than the primary. Okay, so now we are going to discuss some problems where we can apply here. So before entering into this problem, I'm going to tell you, you have seen so far 3 effects. Okay, so you have to give importance like this. So first, while solving problem, give importance to resonance and then your hyperconjugation. Okay, hyperconjugation, please remember this, hyperconjugation, and then comes your inductive effect. So please remember this. The resonance effect is more dominating than the hyperconjugation, and hyperconjugation in turn is more dominating than the inductive effect. Okay, so let's solve the problem. So here they are asking the stability of the alkene. Okay, the stability of, we have read that the most substituted alkene are more stable. So we can see this is what most unsubstituted alkene is also an electron deficient group. So here there is an alkyl group, here 2 alkyl groups, and there are 3 alkyl groups and 4 alkyl groups. So we can say the stability order is like this, and I am going to tell you that there are alpha carbon, this is alpha carbon, alpha carbon, alpha carbon, alpha carbon. This is both are sp2 hybridized. And totally how many protons are there? There are 12 hydrogens. So you can write 12 no bond resonance structure. 12 hyperconjugations are possible, and apart from that, first give importance to hyperconjugation, Hc hyperconjugation. Okay, then the inductive effect, the positive inductive effect. Okay, next I'm giving importance to that. So here how many? So 9 hyperconjugation is possible, and here 6 hyperconjugation, and here 3 hyperconjugation is possible, and here no hyperconjugation. Okay, so that is why this is more stable. And then propene, okay, propene and 1-butene. So this is very important, students. Okay, so here it is an alkene group, it is an alkene group. Okay, it is an alkene group to which a methyl is attached here and an ethyl is attached here. They are asking which is more stable. So you can think that inductive effect, your inductive effect of ethyl is more greater than methyl, isn't it? Your inductive effect plus a inductive effect. But I am telling you, so what you have to think, you have to give importance to hyperconjugation. Here how many hyperconjugations are possible? Here this is the alpha carbon, isn't it? The carbon next to immediate carbon, and how many hydrogens? 3 hydrogens are there. So 3 hyperconjugation structures are possible here. And here what is the alpha carbon? Here it is the alpha carbon, CH2. It has only 2 hydrogens, and you can write only 2 hyperconjugation structure, resonance structure. So which is more stable? This is very important, students. When you think of your plus A effect, you will think that 1-butene is more stable, but you have to give importance to hyperconjugation, and then only your inductive effect has very little effect. Okay, so give least importance to inductive effect while solving these kind of problems. And here see, this is a carbocation, both are carbocation, and what are the functional groups? And here this is ethyl, and this is methyl. So when you think of the inductive effect, the ethyl has more inductive effect when you think of plus I, but think of think about the hyperconjugation and then answer. So here, what is alpha carbon? This is the alpha, 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 and this is the alpha carbon, alpha carbon, alpha carbon, and it has 3 hydrogen, 3 hydrogen. So totally you have 9 hyperconjugation structures you can write. And here 1, 2, 3, 4, 5, 6, only 6 hyperconjugation structures you can write. So which is more stable? This is more stable. Okay, so these kind of questions will be very helpful for your competitive exams. Okay, so here another thing. So your nitrobenzene, while treating with your bromine in presence of FeBr3, what is the product? So first of all, what is the species generated? So when the species generated with this is Br plus, it is an electrophile. Okay, it is an electrophile. So we need a nucleophilic center. It is an electrophile. So we need what? We need a nucleophilic center. But what happens? So we need to think of what kind of guy he is, what kind of effect he will show. Okay, so what are the effects shown by nitro group? So nitro, it has unsaturation, so it will show minus R effect, and it is nitrogen, more electronegative than your carbon, so it will show minus I effect. So both effect are what kind? Both are electron withdrawing. Both effects will withdraw electrons. So it will do what? It will withdraw electrons. Withdraw electrons from benzene. So due to this, what? It will pull all the electrons. So it will make the benzene highly electron deficient. Due to this, the benzene will become highly electron deficient. So if we write the resonance structure, how we will write, I will tell you. For one important point is there, that's why I am going to show this one. See, it will pull electrons. That means what? It will pull electrons. So what happens? Okay, here a positive charge is created, and next in the structure this will move towards here. So it is a benzene ring. Okay, this is a double bond, and this is oxygen. Okay, and if it is shifting, a positive charge is created here, and happens what? And sorry students, the video is little bit lengthy, but it is very useful, I guess. So if this bond moves, we have positive charge. So what happens? Electron deficiency is created on this ortho position, para position, and ortho position. So it makes both ortho position and para position or electron deficient due to the effect. See, one thing I wanted to tell you is, because of this group, both the ortho and para became electron deficient, and in the meta position is unaffected. Both the meta position is unaffected. Okay, are you seeing any positive charge in the meta position? No, only you are seeing the positive sign in the ortho position, in the para position, and again in the ortho position. And in each and every case, the meta is unaffected. So a little bit of electrons will be there in the meta position is left out. Okay, so you will get what? The bromine will come and sit here in the meta position, because it is an electrophile, it wants some electron density, and because of this nitro group, the ortho and para, both the ortho and para has become electron deficient, and little bit electron density will be there only in the meta position only. Okay, so you will get meta-bromobenzene, meta-bromo-nitrobenzene as the major product. That's why we call it as meta-directing group. That is the reason. Okay, and one more thing I wanted to tell you. So here they are asking you, see, they are asking you, in methoxybenzene, if you treat the same reagent bromine in presence of FeBr3, so what will be the product. Okay, so first of all you have to examine what kind of guy he is, what kind of characteristics he will show. So this is a OMe, so this is oxygen. When compared to carbon, this is more electronegative, so it will show a minus I effect. Okay, and it has lone pair, oxygen has lone pair, so it will have plus R effect. Okay, so minus I effect will withdraw electrons, it will withdraw electrons, and it will what? Plus R effect will donate. Both are in opposite direction, both are in opposite direction. So it will what? Decrease electron density, and this will increase the electron density of the benzene. So what I told you, you have to give importance to resonance, hyperconjugation and inductive effect. So always the resonance dominate. So what happens? So due to the inductive effect, it will pull electrons. See, in benzene the outer layer, these are sigma bonds, and how many pi bonds you have? These are pi bonds. These are pi bonds. In the sigma bonds, your inductive effect is happening, and in your pi bond, the plus R effect. So always your resonance dominate. So due to this, it is going to donate electrons. See, the resonance is plus, so it will donate electrons, and due to this, you see here also I want to show you how it is going to be. See, it is going to donate the electrons, and due to the effect, and with what are the positions are going to be enriched with electrons, it is again going to be your ortho and your para position, and not your meta position, So whether the group, okay, is positive or negative, electron donating or electron withdrawing, okay, so you are what I did, okay, so here it is negative. So electron density or seen in the ortho position, or seen in both the ortho position and the para position. Here also the meta is not affected, and you must remember that whether the group is electron donating or withdrawing, always your meta will be unaffected. So it is enriched with electrons. What are the position enriched with electrons? Two ortho position and para position, and not the meta. So this electrophile Br plus is going to come and sit in your ortho and your para. You will get both products, and obviously your para will be major because there is steric hindrance. So what is steric hindrance? They don't want to be, if simple logic, if you have so many seats to occupy, you will occupy which is not congested, right? So it is congested, and when compared to this para, you will get para bromobenzene as a major product, no meta product. Okay, and students, hope you learned something from this video. Feel free to ask if you have any doubts, and please revise the chapter once again, and try to remember. And I told you how to remember logically, and this is very important. And based on this, I'm going to give my next video how to find the basicity and the acidity of the organic compounds, and whether in which these effects are the fundamental things. Okay, if you became very strong in this concept, and that part will be very, very easy. Okay, and thanks for watching. Thank you so much.